Institute for
Sorry, Gavin.
CFCs. All good. For CFCs, and they're primarily used for refrigerants. And if you guys remember, like we talked with them last year, CFCs were the ones that caused the ozone layer problem. So when we went to hydrofluorocarbons, we now have a new problem with that. So first off, I'm going to talk about the applications of hydrofluorocarbons. So as I said prior, they're typically used for cooling and refrigeration. They're also used for insulating foams and aerosol propellants, and they're really a family of compounds that are really endothermic, meaning that they're able to absorb energy and they exist at room temperature as a gas. And what they end up kind of doing is when in a refrigerator system, when they're pressurized, they cool down to a liquid, they release energy, and then when it expands, it absorbs heat energy, and that's primarily what they're used for. So they're all used in a closed system, which is important to understand. Currently, they're the fastest growing greenhouse gas. They are about 1% of the current greenhouse gas levels. As you can see in this diagram here, or this graph, sorry, that most of it exists within developing countries, most of the growth. And as the population grows and as countries start to develop more, they're going to need more air conditioning, more refrigeration, stuff like that. As you can see, like North America and Europe is this blue line right here. I don't know if you guys can see my mouse. Is this blue line right here, and the orange is East, Southeast Asia, and Pacific. And these are the current projections for the growth of HFCs, and this is called the Kigali Amendment mitigation scenario. So this is the goal, this little black line here. They're way more impactful than CO2. So for every ton of, every ton of HFCs, would be equivalent to about 3,790 tons of CO2. Because they're a lot more effective as acting as a greenhouse gas. So they're better at trapping heat. So even that 1% figure of greenhouse gas, that's incredibly significant to the environment. So how are we dealing with the problem? So, currently, actually very recently, the Environmental Protection Agency released an act called the AIM Act, which is the American Innovation and Manufacturing Act. And its biggest focus is to minimize releases. So because most of these systems are in a closed system, there's not actually supposed to really be any like leaks or any sort of releases of this product. But most of the releases happen due to just improper industrial design and like a refrigerator, for example. Also, it's maintenance on the equipment. So there is a lot of opportunity to prevent releases of HFCs, and in general, really they're trying to reduce it 80% by 2050, which would be equivalent to about 70 billion tons of CO2. Another thing that the AIM aims to do is to maximize the reclamation of these products. And that's essentially meaning like physical wasting of the material. Rather than physically wasting this material, they can extract the HFCs from it and then reuse them. And then another aim is to just create a whole new product. So when they phase out HFCs, they want to have products available so that they can meet the demands for developing countries and for North America. Currently, most governments have their own regulations going on right now. I didn't really want to go into it, but each country kind of has their own method to reduce HFCs. And that is my presentation.
Okay, thank you. Thank you for doing that, Gavin. Does anybody have any questions for Gavin? Maybe it's a bit too early in the morning. Can you go back to your second slide?
This one here, this one.
Yeah, that one right there. So you're saying that hydrofluorocarbons are used in insulating foams and aerosol
Yeah, if you
propellants,
look
right?
yeah, I could look at, like, I have like spray on deodorant here, and it literally says on the back that it's there's hydrofluorocarbons in it.
Oh, really?
Hydrofluorocarbon 152A. Yeah.
Yeah.
But they're not released. They only contribute. I have the site right here. I can actually show you. They only contribute to about 5%.
Yeah.
Um,
And what about in insulating foam? So when you see the truck and they pull up and they're going to blast foam insulation material into attics or to coat walls, would they be using HFCs and that
yeah,
kind of foams?
yeah, because it's a property of HFCs is that when you, like, that's why, like, if I shake this can, it's still a liquid.
Yeah.
Right? You can feel it in the liquid, you can feel it slosh around, but as soon as I spray it, it releases the gas. So yeah, it is probably used for spray on foams.
Yeah, I know this was a huge issue. We did lots of work in this field about 15-20 years ago when we were moving from CFCs to HFCs, and I get the point you're making there about a large portion of the the material that's released is through either faulty equipment or from poor maintenance. And theoretically there are regulations in place now that you're not supposed to recharge systems that have been shown to have a leak, right? But it is problematic. I think we're in a better place now than we were 20 years ago when the majority of cooling systems were CFCs. So I think we're in a better place now with the HFCs. But I mean, obviously from your presentation, it's something that we need to do. We need to do more work on, especially when you see those growth curves in your third slide.
Yeah, they expect it to increase about the use of HFCs, and also the use of HFCs, like the release of HFCs, to increase like 10 to 15% about every year.
Yeah. And apparently, I mean, and you can kind of see it in your third slide there too. But apparently, as developing countries, as they do, manage to improve their electricity grid, and as more disposable income becomes available, the growth in air conditioning systems in the developing countries.
Those regulations that you just discussed too, like those countries themselves would also have to implement those. So
right.
Yeah.
Yeah, and by what I've read, a lot of the this is another issue, somewhat akin to the presentation we saw yesterday on plastic being shipped overseas. Apparently, a lot of our excess air conditioning systems end up in third world countries where they get reused, right?
Yeah.
And and the unfortunate part about that is there is no regulations that says they can't be recharged, right?
Yeah. And there's another figure I have from one of the references that shows like how much of it is actually just like from topping up the material and then because of leaks, and then
yeah. Okay, well, thanks for doing your presentation, Gavin. That was actually very interesting.
No problem.
Okay, all right, so let's see who we have next on our nobody has any questions for Gavin before we move on to the next one. Okay, so Natalie Hickson.
Yeah.
Are you?
So I'm just going to. Does everyone see that?
Yep, it just popped up now.
Okay, great. Okay. So today I'll be presenting effluent streams generated by a nuclear facility. I'm currently working as a chem tech at the nuclear power plant in Pickering, but when I was a student, I spent my 5 months there in the environmental lab. And my main responsibilities were to maintain, sample, and test the different effluent streams throughout the plant. Therefore, my information is going to be very directed towards the OPG generation station. However, the information is universal for most nuclear stations. So how does it work? So I don't know how many of you know exactly how nuclear energy works or has a little bit of a comprehension of it, but I do feel it's a little bit important to know why we monitor these effluent streams. So there is a great YouTube video. I'll post it in my PowerPoint, but it's a little bit lengthy. So I just took a couple screenshots. So in general, I guess, OPG nuclear generation stations use naturally occurring uranium, and we split up this atom in the fuel with a process called fission. And this occurs when the uranium atom is bombarded with neutrons. The result is that extreme amount of energy is released, and this is transferred to our heat transport system. And that's what you see here in blue. So this would be in blue. You can see that this is a cooled closed loop system. It travels through the reactor, picks up the thermal energy from the fuel, and then it transfers it to our boilers. Now our boilers is a light water system. Once it becomes supersaturated heat, it is used in turn to turn. It will go up the stack, and in turn it turns our turbine. And then in turn that turns our generator, and that's how we create electricity. So as you can see from a CANDU reactor, and these are the reactors that we have here at Pickering and at Darlington, we use a lot of water in the form of steam and in the form of liquid. So it's really important that we ensure that we measure and we know exactly how much of this is being released into the environment. So effluent and environmental monitoring are regulated activities that must be performed in order to quantify the amount of nuclear and hazardous substances that are released into the environment as a consequence of the daily operations of a nuclear facility. So there's two different types of steams I will be talking about, not steams, sorry, effluent streams. So there's the gaseous. So this is just steams and radionuclides, which make their way up the stacks. And this is the Pickering plant. I guess that's on the right. And in green, I just showed an arrow of a couple of our stacks. And then I'll be talking about liquid effluent streams. And this is any liquid which is emitted from the plant and make its way into our lake or a public sewage system. So in blue, you can see the arrows that are our forebays. So those are our intake of water into the plant. And the red, that's our outtake. So that's where we're putting it back into Lake Ontario. So what exactly is being monitored in our effluent streams? So there's obviously radioactivity, so the concentration of nuclear substances. There's the concentration of hazardous substances, such anything that's toxic, corrosion, or really has a negative effect on the environment. And then there's also physical characteristics, which could include temperature, pH, volume, or density. Now, what is the biggest hazard when it comes to a nuclear facility for like a CANDU reactor? Now, this would be tritium, which is a radioactive isotope of hydrogen. This occurs when deuterium or hydrogen gets bombarded with neutrons. Now, tritium has an effective half-life of 10 days, which means it takes that amount of time for the radionuclide to decrease by half of its initial value as a result of both radioactive decay or biological elimination. So that's how long it will affect inside of a human body if you have an intake. However, in the environment, it has a decay half-life of 12.3 years, and therefore it's extremely important to quantify, to analyze, and to know exactly how much is being released into the environment. So when we're talking about gaseous effluent streams, stack monitors are installed throughout various locations throughout the plant, and this is to measure radioactive airborne releases. So stack samples are collected and analyzed for tritium, carbon-14, radioiodine, and radioactive particulates. And if you remembered, Stuart went over a couple of like how we monitor that in a couple of classes ago. So additionally, we do monitor the steam and we condense it in order to quantify the percentage of the steam that's heavy water or light water. Now, this is not really for an environmental aspect per se, but heavy water is extremely expensive, and we want to make sure and limit the amount that's going up our stacks. When we're talking about liquid effluent streams, sample analysis results are used and calculated to report radiological releases. We also want to analyze the streams for concentrations of oxygen, chlorine, the pH, and also the variant of temperature between the water intake and outtake. And if you could see in the background, that dome shape in the back, no, I have no mouse. Oh, I do have a mouse. This here, this is our unit 4 reactor. And I would say it's about 150 meters from a public beach. So these are people swimming in the beach. So it's extremely important for us to know exactly what we're putting into the lake in order to protect the public. A little side note, I'll just talk about chlorine. So at Pickering and at Darlington, we have a really big zebra mussel issue. And, you know, they go into our pipework, they grow, and then it causes a huge problem. So we add chlorine into our system in order to eliminate that. But we can't just put a huge concentration of chlorine into the lake. So we use another chemical that reacts with the chlorine. However, in turn, this affects the dissolved oxygen in water. It affects the pH. So these are all things that we have to monitor because we don't want this to become like toxic for marine life. Additionally, the temperature of the lake is extremely important to monitor. We use a lot of the water from the lake as heat exchangers, not to cool the fuel per se, but to recondense the steam, to cool a part of our another closed loop systems. And for the short time that I've been working there, we had to downgrade a couple of our reactors because the heat output was too high given the regulations, like what we were able to release. So it's an extremely important characteristic to ensure that's in spec. So how do we monitor these releases? So there's a couple of different ways. There's grab samples, which is a single sample or measurement taken at a specific time and location. And this is more like a snapshot in time. There's continuous or composite sampling, which is required when effluent qualities may vary over a period of interest. So we may set up a sampling system and which would take aliquots over a period of time. And then we would analyze the composite that we've achieved from that sampling unit. And then we also have online instruments, which are used in order to get a real-time reading and indicate if any unexpected high releases are observed. So those are just my references. So if anyone has any questions.
Okay, thank you very much, Natalie. That was very interesting. Does anyone from the class have any questions for Natalie? So it doesn't sound like it. I have a few questions. You had mentioned earlier that you worked at or you did a placement at the environmental lab.
Yeah.
Is that the lab in Whitby?
No, so that's a different lab. They mostly go. So I worked in the environmental section at Fort Pickering plant. So there is a lab at Whitby, but they do more, they would test like outskirts of the plants to see if anything gets released. It's more like farms to see if it's affecting any of like the agriculture around the plant. I'm not 100%. I do have one coworker that used to work there, but they more deal with not stuff directly related to the power plant.
Yeah, we actually did the environmental compliance approval for that facility, and a lot of the samples that were going through there were, you know, soil samples that they collect from farm fields and fish samples that had been collected from the lake. I just want to clarify something, and it's actually on this slide that we can see right now. Yeah. Did you said the tritium half-life in the environment? Did you say it was 12.5 years?
12.3 years, yeah.
That's the half-life?
That's the half-life, yeah.
Yeah, okay, yeah, so that, I mean, it's obviously something that you'd want to make sure that, you know, the releases of tritium are well under control, right?
Yeah, and there's regulations set, and then OPG has their own set of regulations, so it's a lot lower than what we're actually allowed to release, because tritium is a low beta emitter, so it would have, you know, if there was a large outtake that was put into the lake, it would be pretty severe, but like not that I am aware of, we definitely make sure that we're well below what is acceptable.
Yeah, I know there was a lot of talk in the news going back probably easily 10 years ago about the amount of tritium that was being released into the lake, because just to the east of the plant is the main intake for the one of the water treatment plants, right?
Yeah, it's like
So
right beside, yeah.
yeah. So there was a lot of concern about that. How significant is the zebra mussel issue now?
It's a very big issue. So right now it depends on temperature. So we actually just took chlorine out of service, but that would be one of our main problems. I've seen they had to remove a huge piece of piping, and just from the inside I could see the damage that would occur. And even in some of our sampling containers, they would make their way up the line, and in my containers itself you would find like little zebra mussels. So yeah, it's definitely like, obviously chlorine, it is an expense, and it's not something that they want to be doing, but it's definitely detrimental for our system.
Yeah. So I mean, obviously, it's I remember a few years back, you take a walk along the beach in Whitby, and there would be mounds of zebra mussels on the beach. But then I took a walk down there a couple of weeks ago, and there was hardly any zebra mussels in sight. So I was somewhat hopeful that maybe the zebra mussel issue is getting a bit better, but it doesn't sound
It
like it.
might, yeah, it might just depend on the temperature, like the time of year. Like we put chlorine out of service a couple of weeks ago. So maybe that, like, if you went
Yeah.
maybe a while, like a month ago, maybe at that point it would have been bad. But
Yeah.
yeah, with the decrease of temperature, obviously that becomes less of an issue.
Yeah, and one last question. I don't want to be taking up all the time here, but how does the heavy water get into the exhaust system? Because it's
So
in a
it's
closed loop
not,
system, right?
yeah, it's not, it's usually from leaks. So we do have, because everything is super pressurized, we do have a lot of leaks, and we try to contain those leaks. But sometimes, just as a chem tech, I'm sampling some heavy water, and if I spill a little bit inside of the reactor building and something gets released, then at that time, we have to ensure that, well, that's a way for it to get put up our stacks. It's very minimal. We do sample like all of the units to make sure, and it's like usually it's less than 1% of heavy water that's being released. But even then, over a period of time with that calculation, it can add up. And it's like, I forget the exact amount, but heavy water is extremely expensive and we use a lot of it. So we just want to ensure that I'm not 100% sure, but I don't think it has, because there is natural deuterium like in
Right.
the atmosphere.
Yeah.
So the amount that we're releasing isn't an environmental concern, but we want to ensure that we're collecting as much of our leaks and our losses as possible.
Yeah, and I guess that's that could be used as an early warning system that potentially you have a leak developing somewhere, right?
Exactly. Yeah.
Yeah,
You're
yeah.
absolutely correct.
Yeah. Okay. Well, thank you very much, Natalie. That was very, very informative. Okay, so we will move on. Melissa Joven, are you ready to go?
Yeah.
Okay, and we can hear you, so you're good.
Can everyone see it?
I just have to flick back. Yep, I can see it.
Perfect. All right, so my presentation is on landfill mining. For those of you who don't know, landfill mining is the process of excavation of waste in the landfill. And the goal of landfill mining is to remove hazardous waste from the landfill to allow for the landfill to be cleaned or remediated. And some of these benefits include reducing leachate plume, which is contaminated groundwater beneath the landfill, and reducing greenhouse gases, which we just watched Gavin's presentation, so we should all really know what greenhouse gases are. And in the case of landfill mining, we would look to reduce methane that is being released. So this was a case study from a Blackstock landfill mining. So I won't read that section. It is in homework, I believe, 3 in one of the ESA reports, and it's page 10, as you can see. But to summarize, the testing tested how Durham could eliminate or greatly reduce the leachate plumes and the greenhouse gases at Blackstock landfill site. And so the goal was to return the landfill to its pre-landfill state through landfill mining. So the waste that was excavated and then separated from the waste in the soil, and it's placed into a rotating trommel screen. And then the metal and concrete is sorted out and recycled. And the combustible waste was transported to Durham York Energy Center for energy recovery. And the non-combustible waste was sent to Twin Peaks Environmental Center. So this is a nice little pie chart that I've made. It's not actually that nice, it's only 4 things, but it's there. So combustible waste, the total amount of waste was 4,796 tons. And combustible waste was 2,849 of that. The non-combustible was 1,974 tons. The concrete was 160 and the metal was 98. So like I said, the combustible waste was sent to Durham York Energy Center for energy reclamation, and non-combustible waste was sent to Twin Creeks landfill. The concrete and the metal was recycled. So is there a downside to landfill mining? Like, is it actually good or is it bad? Personally, I think it's good, but there are some factors that you do need to look into. Like, the downside is, are we emitting more greenhouse gases by just transporting or doing the mining than we would have saved by leaving it there? So I did a calculation just for the combustible waste and the non-combustible waste for the transportation of those wastes. And as you can see, the 2,849 tons, and then you multiplied it by miles, and then you got the ton miles. And from the ton miles, you multiplied it by 161.8 grams CO2, which was the average freight truck emission per ton mile. Then you got the grams of CO2. And then from the grams of CO2 divided by a million to get the metric tonnage. So for the actual whole project, just for transporting the combustible waste and the non-combustible waste, I found that you could accumulate at least 73.59 metric tons of CO2. I'm sorry, and there's my references.
Okay, thanks. Thank you, Melissa. Does anyone have any questions for Melissa? No questions? I have one issue with one thing you said, where you said your graph wasn't that nice. I really like to see graphs. It really allows you to visualize the information that you're putting that you're trying to get across. And I actually think you did a good job on that graph. So I don't know if this would be a hard thing for you to assess, but do you think is the amount of greenhouse gases that are emitted from the remediation project by shipping all this material to off-site locations, would that be significantly higher than what you would generate from the waste if it was just left in place, do you think?
I think in that case, probably it was better to mine it. But
Yeah.
I think if it was if they collected way more waste, it definitely wouldn't be, because they wouldn't, you can only carry about 2,000, I can't remember if it's 2,000 pounds, 2,000 kilograms for the average freight truck. So you'd have to do at least 2 or 3 trips if it was more than what we had. Like, we only had 4,876 in total. Yeah. So the 2 trucks would have just been fine.
Yeah, I think in this case, part of the downside was because they were shipping it off to a significant portion of the waste was being shipped to a landfill that was a significant distance away. But that being the I think it's called the Twin Creeks landfill. I mean, if it could be dealt with, closer to the landfill that's being mined, it would be better, right? So
Yeah.
yeah, I mean, it's a very interesting perspective that you put on it, Melissa, and thanks for doing that. Anyone else have any questions for Melissa? No, sounds like you're done, Melissa. And so next up is Tegan. You ready to go, Tegan?
Yep. Can you see that?
Let me see.
Okay, just give me 1 second. All right, so I'm going to be doing my presentation on the effect of textile waste on wastewater. So I'm going to start off by just saying what is textile waste. So it can be separated into 2 different kind of categories, pre and post-consumer waste. And pre-consumer waste is the waste that's produced during the manufacturing process of textile production. And then post-consumer waste is the waste that the consumer produces when they dispose of their old textiles. So some of the environmental concerns of the textile industry is that it's been found that 17 to 20% of all industrial wastewater is produced by the chemicals used to dye and finish textile products. And these can include things like suspended solids, metals like cobalt, copper, and chromium. Those are kind of some of the ones of like higher concern, as well as sulfates, oil, and grease. And it's been found that 2 billion liters of colored effluent is caused by the dyeing used in the textile industry each year. And so why are these chemicals not being treated before they're being disposed of? So most of the stuff that is being disposed of can be treated with proper wastewater treatment plants, but this isn't happening because the countries that these textiles are being produced in are unwilling to meet government regulations, and the government isn't enforcing them to meet these standards. And then on top of that, the cost of making these treatment plants is so high that the companies just aren't willing to put in the money to actually do this. So the effluent treatment process that they would be encouraged to implement, that the government says that they should have, would be a effluent treatment process. And this is just a little picture of that. So you'd start with the, where is it? So you'd start with the equalization tanks, which would be used to ensure that the effluent is at the correct pH before it goes into the whole treatment process. And then you would go into the aerobic, oh my gosh, sorry, I can't pronounce it, process, which is used to, it introduces oxygen into the effluent to help it break down organic components. And then it would get pushed into the clarifier, which is used to remove the suspended solids from the effluent. Then it would go through an activated carbon filter, which would absorb the contaminants into the filter, like microplastics and chlorine. And then it would go into the ozonation process, which would increase the dissolved oxygen concentration. And then it would go into an ultrafiltration, which would then allow it to be, which is used to recycle and reuse the water that contains no solid in them. Then the reverse osmosis unit, which is used to remove any remaining impurities without using any chemicals. And then it would just go into the storage tank to be used again. So there are companies that are working with the people in other, with these companies that are helping them use these different 10 practices to help them reduce the amount of environmental impact and help them save money without having to introduce the effluent treatment process. This company is called Clean by Design, and they worked with major manufacturers. And by implementing these 10 different practices, they were able to reduce chemicals used by 400 tons, reduce water use by 36%, and reduce energy use by 22%. And then there are my references. So.
Okay, thank you very much, Tegan. You guys are really dragging me down memory lane with these presentations. When any of the sites that you looked at, did you come across the Environment Canada textile mill regulations at all?
No, I didn't, to be honest. I ended up going down a little rabbit hole of textile waste, actually just in Bangladesh, and that's where I just kind of like tunneled into that.
Yeah. So,
So-
Environment Canada came out with textile mill regulations probably about 15 years ago, and we actually had 4 or 5 textile mills as clients, and in order to meet the textile mill regulations, you know, the mills had to have in place, pollution prevention plans, but their mill effluent also had to meet a toxicological test. We had to send samples of the mill effluent off to a lab, and they counted how many Daphnia magna was killed by the effluent. And I can't remember what the limit was, but it was a pretty strict limit, and
Yeah.
none of our clients could meet the limit. And unfortunately, their solution to the problem was they shut the mills that they were operating in Canada, and they moved them to places like Bangladesh. A lot of them went to Turkey, and I remember talking to one of the process engineers at one of the mills, and he said, we're shutting these mills down, we're putting all these people out of work, we're moving it all to developing countries. And he said, I went there and the work conditions are horrible. And he showed me some photographs of the discharges from these mills. And I mean, rivers moving through villages, where they were bright red, bright green. So just another classic example of let's ship our issues off to developing countries, and we won't see it, and everything will be fine. So so I found your presentation very interesting. Does anyone else have any questions for Tegan? No. No, okay. Looks like you're done, Tegan. Okay, so
Okay.
thank you very much for doing that.
Thank you.
Okay, so who do we have? Who do we have up next? Andrew Larson. You ready to go, Andrew?
Yeah, I think I'm pretty set.
Okay.
Let me share my screen. We share Google Chrome. I think it's. Oh, hold
you're-
on. I gotta change my settings. Sorry.
That's okay. You're struggling with the same things that I struggle with when I come on to do these Zoom lectures.
Yeah.
Our days may be limited on doing these. Maybe hopefully we all get back into a classroom setting next semester.
Yeah. Hopefully.
Yeah.
All right. I think it should share now. Just gotta. Oh wait, hold on.
It's okay.
Okay, there we go.
You got it.
There, okay. Yeah, I had to change some settings around. Okay, so this is similar to I think Michael's presentation yesterday on how we are the largest producer of waste in the world, which is like crazy to think of since we only have like 30 million people in our country. That's just mind-boggling to me. So I thought this was kind of a neat thing to touch up on my presentation. So first slide is just data that I've gathered. So Canada produces around 36.1 tons of waste per capita, which is 10 tons more than the US. And the US has like a much larger population than us. So we produce a lot like individually. And that totals to 1.33 billion tons total each year, just about. And only 9% of this total waste gets recycled and reused. So the rest of it ends up in just landfills or gets shipped off overseas, which is like a problem that we specifically have where we just ship our problems, away, out of sight, doesn't bother us, it's kind of needs to stop. About 29,000 tons of this gets into the environment, which is, that's a lot, into oceans, forests, side of the road, highways. You see a lot of trash on the side of the road. And 86% of it ends up in landfills specifically. So, yeah. So the impacts of this: landfill sites, of course, take up a ton of space, and potential habitats for animals are being destroyed because of this. People are demolishing, places, or rezoning places, and digging these big pits and just, putting stuff in the ground. It's pretty gross, but yeah. And incineration isn't much better either. It just creates tons of pollution. The heavy metals are being released into the air, which is awful for breathing or air quality. Dioxins, mercury, BCPs specifically are the main ones that are released by plastics. And animals are dying pretty much, and they're mistaking plastic for food. So I don't know if you've seen that image of, like, I think it was like a seagull or a bird or something like that, but it was dead, and it was sort of cut open, and there was, like, it was filled with plastic. I didn't want to put it on the slide because it's kind of gross, but yeah. So yeah. And now, what is being done? What is the Canadian government doing? What can we do? So as you've probably heard, they're banning single-use plastics, or have already taken the steps to ban that. The ones that are found in the environment, and they're providing available alternatives like metal straws, paper straws. I kind of want to get a metal straw, so I might do that eventually. And another thing is they're cleaning up plastic pollution in water systems and wild environments. So they're paying people to go out and, find trash and stuff like that. And yeah, I think there was a thing in my school that we did where we took a day off to just like clean stuff off the streets. And that was like a whole thing that we did. So I guess I think that might also be part of, their thing. And other things, they're providing awareness of this issue to like companies. They're contacting businesses. As I said, they're also contacting schools about it. They're also providing alternatives to agriculture, industry, and consumers. So as I said, like plastic straws, stuff like that. And they're also doing a addition to SEPA laws, which is, they're trying to, put plastic into the toxic chemicals list, pretty much. So they're trying to, limit that even more. So yeah, so these are my references, and that's my presentation.
Okay, thank you, Andrew. Anyone have any questions for Andrew? No questions from your fellow students. It seems like it seems like a fair number of students are doing the presentations on plastics, and I mean, it really just is highlighting the problem with plastic. So I have a couple of questions for you. You give that statistic, right? That we're producing, I believe it was like 10 tons per person more per capita than in the US, right?
Yeah.
Yeah. Did you get any sense that might just be based on when in finance they look at the economies of scale? If you have more people it's cheaper to service more people than it is to service a lower amount of people. Could it be that they just have greater economies of scale, so they can produce materials with less waste per person? You think could that be
Yeah,
playing into?
I think it's more rationed over there, I guess you could say,
Yeah,
where, it's yeah, unlike over here where, we're more free to, I guess, waste things, if that makes sense. That
yeah,
kind of sounds bad, but
yeah.
you know, um
You would certainly think with the amount of waste that we're producing, if we're producing 36.1 tons of waste per person in Canada, that we would be more aggressively going after this as a society to attempt to reduce it, right?
yeah.
A couple of things that I was going to point out. It feeds into where you mentioned, plastics in water. And Tegan had done her presentation on textiles and the effluent from textiles. But we also have this huge issue developing, and I don't know if anybody's going to do a presentation on it, but we have the huge issue of microplastics in water, right? And if you ever want to check something out, go to Georgian Bay Forever's website. They're working with a project. I believe the federal government's involved in it and the provincial government, in which they're putting filters on people's washing machines. And
Oh,
these
really?
filters are specifically designed to capture microfibers that come from textiles, right? And apparently, the amount of plastic fibers that are being collected by these filters is even surprising, the people who thought this project up. So maybe that's something we all end up doing, is putting filters on our washing machines to help reduce it. And the other thing I just kind of wanted to say about this too, about you highlighted this, I mean, the garbage and plastics in particular are just they're just everywhere in the environment. And I did some work with I did some work with a local group a little while back, and we were out in the woods picking up plastic waste, and it was amazing how when you would pick up like a plastic motor oil container that somebody had just thrown away into the woods, and it sat there and degraded it. And as we picked these things up, they would just crumble in their hands because they'd been there for so long. And it actually got to the point where you couldn't pick it all up because it just broke down into such fine pieces. And it was just a real eye opener as to how microplastics, one pathway for microplastics to end up in the environment.
Yeah.
Yeah. So, and I like your slide here. Only 9% of the total waste gets recycled and reused. So I think we have a lot of work to do there. And as your slide says, 29,000 tons get into the environment. And I was listening to a CBC show last night, and they were talking to a professor from a university who is working to develop a natural-based glitter. So those little fine glitter material that we buy. We can throw glitter, we can decorate with glitter. You would never think of it as being a problem, but apparently the amount of glitter that ends up in the environment is just massive. So they're looking at trying to do something with even that. But yeah, no, I enjoyed your presentation. So thank you very much for doing that.
Melissa asked a question. I don't know if you want me to answer that, but I think
if you can, yeah.
Yeah, I think I do sort of have an answer to that. So I believe BPAs can affect like people. I believe it can affect your reproductive like organs somewhat. But I'm not sure about aquatic life specifically or animals. I assume it would be a very similar thing for animals, but yeah, I just want to touch up on that. So
yeah. No, I think you're right. BPA, which is bisphenol can't remember what the A stands for, but yeah, they're synthetic estrogens, and they do have significant impacts on humans and also aquatic and land-based animals as well. Because anytime you throw a synthetic estrogen out there, it has the potential to just to mess with reproductive systems, right?
Yeah.
Yeah. Okay. All right.
Right.
Thank you very much for doing that, Andrew.
All right. Thanks. How do I unshare this? Oh, there.
I kind of felt for Andrew a little bit there at the beginning of his presentation. I took a virtual conference a couple of weeks back, and there were hundreds of people on the conference, and one of the presenters could not get his screen share to work, and he struggled for about 10 minutes trying to get it work, and he just got more upset the longer he went, and he never was able to get it to work. So I mean, sometimes we struggle with technology, and but Andrew managed to overcome that quickly and with no downside. So Braden, are you ready to go?
Yes, I am.
Okay, all right. So if you'd like to start, Braden.
All right, perfect. So today I'll be talking to you guys about slag. So first, I'd like to start off just explaining what slag is, because not everyone knows. It just refers to the crud or the stuff that floats on top of liquid or molten metal. As you can see here, I don't know if you guys can see my mouse, but they're kind of poking it with a stick here. It's just that crud floating at the top. And slag is a byproduct of metallurgy combustion processes, such as like smelting, welding, etc. Slag is just the impurities of the metal. It's found in ores, scrap metal. It's just an oxide mixed with an element like sulfur, phosphorus, aluminum. The list goes on and on. Usually when people refer to slag, they're referring to iron or steel, also known as like ferrous slag. So how is slag produced? It's less so produced more as a byproduct of trying to get the main material wanted, i.e. your metal, or in this case, a very nice weld, where you have to get all that crud off. So looking briefly at the history of slag, it was just originally given away because manufacturers didn't really have much use for it. They didn't know what to do with it. So they just give it away to people. And then it was discovered to be pretty good for aggregates. But in 1998, it was discovered by, I believe, a Stanford student to actually leachate harmful things just due to natural weathering conditions, or at least 1998 is when the paper was posted. And then in 1963, the same student, forgive my pronunciation, was sampling in Comanche Lake, downstream from a mining facility, where each year for 6 months it floods, causing the flooding water to run through 250,000 cubic yards of this material, which provided high levels of cadmium, copper, and zinc from the reservoir lake. And these levels were determined to not meet the EPA chronic toxicity guidelines, meaning it would harm aquatic life. So it's important to explain the difference between slag. Some slags are relatively harmless, like ferrous slag is considered to be relatively inert, whereas other ones, such as the ones produced from the refining of copper and zinc, produce more toxic, harmful things. So some slags contain elements such as arsenic, lead, and cadmium, whereas other ones, such as the ferrous one mentioned previously, only contains iron, calcium, etc. So what's different now than it was previously? Well, now we recover the metals such as nickel, zinc, lead, iron. This is mostly due to cost-effective measures, but also helps with contamination of the environment. So as I said previously, the industry says that ferrous slag is relatively inert, but there was a study done in, I believe, 2008 for foundry slags from gray iron foundries. 2 were deemed to be okay for unrestricted use due to the leachate levels, whereas the other 2 were determined to need restrictions as they leached too much iron and manganese. And finally, what it's used for. So now, because we can engineer it for its porosity and size, the 2 main components of making composites for its use in asphalt and concrete, it's much more useful in industry, as well as it can be used in the environment for acid neutralization and the removal of phosphate because of the calcium found in it. But if you look to the photo, this is what happens when you treat it with it. It tends to pollute the water that you're treating with iron. And finally, before I get into questions, I would just like to state there is a Canadian Association for Slag, but it's pretty bare bones and doesn't give you much information. So with that said, is there any questions?
Okay, thanks for doing that presentation, Braden. Anyone have any questions for Braden? No questions. I know we've had many problems with slag when we're doing environmental assessments at sites, because, as you mentioned, Braden, for many years it was a waste product that nobody knew what to do with, but it was given away to people. I guess one of the examples of that is Port Hope, and how waste material from the old chemical plant down there ended up distributed through the town, because it was essentially just given away to be used as fill material in various areas. And what we found while doing environmental assessments is that the slag, over time, excuse me, will break down into very fine particles, and it's those fine particles that would cause issues during environmental site assessments. Did you come across any creative uses or potential new uses for some of the slag material?
So I thought it was interesting that they decided to use it for acid neutralization, because acids are the main reason why it breaks down in concrete, because the acid goes in and takes out the calcium and also happens to remove metal with it. So I thought it was interesting to use it for that.
Yeah, that's actually a use I've never heard of. So you're right, it is interesting that they're using it for that, right?
Yeah, but it's a relatively double-edged sword because it does cause iron pollution. I don't know off the back of my hand what the iron pollution levels are considered to be too high, but I would consider, like in this, or Red Lake River is kind of not acceptable in my opinion.
Yeah, so interestingly, iron is something that we really struggle with, because if you we have facilities that the stormwater will be high in iron, but like you say, there are very few regulations on how much iron you can discharge, right? And as you mentioned, the Red River in your slide is clearly unacceptable, right? But what level of iron in natural water bodies is acceptable? It's a little bit of an unknown, right?
Mm-hmm.
Yeah,
because the companies try and say that, oh, it's inert, so we can dispose of it in landfills, etc. But I know they can use it. I didn't talk about this because I don't know much about bacteria, but I know they use the slag to treat microbes, and somehow it helps them. I don't have a strong grasp of it, but I know they use it for that.
Yeah, I mean, there are iron oxidizing bacteria out there, right? So potentially, I guess they're using it in some way, shape, or form to deal with iron oxidizing bacteria, or to promote their growth, maybe. So, okay, well, thank you for your presentation, Andrew. That was very interesting. Okay, so we will move right along. I will see if I can. Andrew, can you stop sharing your screen?
Sorry, I'm trying to.
Yeah, no, that's fine. Yeah, it's just for some reason it has my screen frozen. But okay, I got it now. All right, so who is up next? Visna. Okay, Visna, you ready to go?
Yes, I'm ready to go.
Okay.
Okay, just a second. Can you see my screen?
Yes, we can.
Okay. My presentation is about the waste that is generated during the processes that occur in the water treatment and wastewater treatment industry. Water that enters in the water treatment plants, for example, from Lake Ontario, is pretty clean. Usually the turbidity is just 0.1 NTU, but considering that daily I process approximately about 200 megaliters of water in large municipal water treatment plants, lots of the materials that are present in the water get concentrated. As well, in the processes of coagulations and loculations, a lot of chemicals, coagulants like alum, polymers that are coagulation aids are used. Acids and bases are used for a pH adjustment. And especially the water that is used for backwashing of the filters gets really highly concentrated with those contaminants. This is how it looks, the water that is used for backwashing of the filters. In this water, somehow certain amount of protozoa and algae also end up stuck on the filters. And all those materials are very concentrated, and the wastewater that exits from the backwashing of the filters is more than the allowable maximum concentrations that allow for discharge of the waters. And this water cannot just be dumped in the lake because those substances are harmful for the health, human's health, and for the environment. And it just needs to be treated. In the water treatment plants, the large water treatment plants, this backwash water from the backwashing of the filters together with the sludge that is collected from the bottom of the sedimentation tanks is directly pumped to the nearest wastewater treatment facilities. In the wastewater treatment facilities, there are usually primary and secondary treatment. Tertiary treatment is not everywhere available in the water treatment plant, in the wastewater treatment plants. And sludge is collected from all of these processes. In the primary treatment, the sludge mostly is from the coarse screening, grit, and slit removal. And usually by this process, about 35% of the organics is removed and up to 65% of the total suspendable solids. The secondary treatment is mostly biological and oxidation processes where microorganisms are involved in those processes. And this combination of microorganisms and wastewater, where the microorganisms are well adjusted to the wastewater, is called activated sludge. From the exit of this aeration tank, usually by 30% of the activated sludge is recycled and it goes back at the beginning of the oxidation tank. But the rest of, and this amount of 30% is good to maintain the process continuously. The rest of the sludge, it must be disposed somehow. Tertiary treatment, as I mentioned, is not available in all plants. mostly means additional removal of the organics and total sustainable solids. It removes the difference between 85 from the second treatment and 99.9%, which means that the quality of the water with tertiary treatment is almost like drinking water quality. And this one is especially important for removal of the phosphorus and nitrogen. All these sludges that are collected from the processes contain certain amount of water that is valuable to be, to be discharged in the environment or to be reused for the processes. And it's very important to be decrease the amount of the water of the sludge. The sludge usually contains 3 to 7% of solids, and in this situation is not liftable. I mean, it's not easy to be handled mechanically. If the water is decreased is greatly decreased, so the concentration of the solids increased to 40%, which is called sludge cake. In this, with this consistency, the sludge can be easily handled and mechanically can be handled. Another options for the sludge to be treated is incineration, which is that the sludge passes through high temperature furnace, where at temperatures of 800 to 1000 degrees Celsius is burned to ash, but there another problem occurs with the pollution of the air. So frequent monitoring of and sampling and testing is required for the obtained ash and for the exhausted air. Another process that can be applied to the sludge is digestion. It can be done in aerobic and anaerobic conditions with the presence of microorganisms. Aerobic is usually done with extended aeration or pure oxygen. For anaerobic digestion, are present anaerobic microorganisms. Both are done at 37 degrees temperature. And for the anaerobic, it's important production of methane gas, not just that is valuable as an energy source, but also the production of the methane gas is indicator that the process is well functioning. Another option for the sludge is composting. When at the end of this process, the sludge looks like topsoil, and it can be reused as a filler, mostly for lawns and golf courses. The level of contaminants in the compost is below the detectable limit, and it doesn't contain any vectors for transmissible diseases. But still, this compost cannot be used, let's say, for home gardening, for maybe for flowers, but not for planting vegetables. All these processes that I mentioned so far mostly refer to the disposal of the sludge. I would like to mention one process that mostly is applicable for small water treatment plants in rural areas where the space is not limited. Practice is to be the wastewater to be placed in a shallow lagoons, where by natural forces the degradation happens with atmospheric oxygen. Among those processes is important irrigation, which is a very slow process, but is very effective because the plants, the vegetation plays an important role in the degradation of the impurities, and the quality is compared to 99.9% similar to the tertiary treatment of the wastewater. Another process is infiltration, which is a much faster process, but because it's faster, the plants doesn't play much role in the nitrogen removal. So nitrogen removal is not very effective. And the last process is land overflow, where the wastewater in thin film flows over an inclined, unpermeable surface. And this land is not very effective for the phosphorus removal. This concludes my presentation regarding the waste management options for water treatment and wastewater treatment industry. If you have any questions, now is the time to ask. These are my references.
Okay, thank you very much, Vesna. Does anyone have any questions for Vesna? No questions. That must mean that you answered everyone's questions in your presentation. I have one. I probably have a couple of questions for you, but the first couple of slides seem to deal with water treatment, so potable water treatment.
Yes, I wanted on first side, the water treatment seems like there's not so much waste,
Yeah.
but I wanted to put together both of them because as I mentioned on that slide, this is how the water looks after the backwashing of the filters, and it's gross, it's not very
Yeah.
clean, and this water goes directly in the nearest wastewater treatment plant. That connections I wanted to present for both.
Okay, yeah. So that was the question that I had is what is their waste disposal method for that water? Is that how they deal with it? They essentially dump it to the sanitary sewer and it goes to the wastewater treatment plant for treatment?
Yes, that's correct for large water treatment plants. Especially I'm talking for one that is for Horgan water treatment plant that is under City of Toronto.
Yeah.
And always those plants are next to each other.
Yeah. Yeah, no, it's something that I had actually never given any thought to, is that yes, there's waste being generated from the water treatment process as well, and I find it quite interesting that they're essentially just sending this over to their to the other side of the coin and sending it to the sewage treatment plant. Did you when you were looking at the sludge from the wastewater treatment plants, did you look at things like metal content of that sludge, or is there any controls on the use of that sludge to be used on agricultural fields? Or
specifically, I didn't look at any content, but it's assumed that sludge contains certain harmful materials, and depends which process will go. Let's say in incineration, most of those materials are distracted by the heat, and then whatever goes in the ash should be controlled. So if there is a high concentration of heavy materials, whatever is present in the ash, I assume that it won't be used for that purpose.
Yeah.
But for the other processes, those like digestion, most of the materials get degraded by the microorganisms.
yeah,
Even even
Sorry,
for
go
the
ahead.
compost was mentioned that there are like grades, 2 grades of compost, but both of them are below the detectable level, but still is stated that the impurities are present, and they're used mostly for golf courses, for lawns.
Yeah, I know. Municipalities. The cheapest way for them to deal with their sludge is to use it as a soil amendment on agricultural fields. And part of the reason for that is because there is a fairly significant phosphorus and nitrogen content associated with the sludge, but they do struggle and able to use it as soil amendments, because imagine a city the size of Toronto, you have all those industries, that are discharged into the sanitary sewer system, and even if they're discharging metals, that are at the levels that are compliant with the bylaw limit, those metals tend to accumulate in the sludge, and I believe that is the biggest reason why they have to redirect the sludge from soil amendment uses to things like incineration. We did a study of various industries, and when you look at some of these large plants, they're discharged and effluent at compliant levels, but when you look at the mass loading to the sewer, some of them can be released in 30-40 kilograms a day of heavy metals, and those heavy metals are essentially ending up in the sludge that's being generated from these wastewater treatment facilities. So it's definitely an issue. Okay, well, thank you for doing that, Vishna. It was very well done. I'm just going to sit and record all these presentations you guys are doing today, and then instead of me having to do my lectures next year, I'm just going to replay these, because you have so much good information in them. So okay, I think what we should do is we should just continue going, and not take a break, and see if we can just get through today's group before 10 o'clock comes along. Okay, so Omar, are you with us today, and are you ready to present?
Yes, I am ready. Could you give me a second? Just a sec.
Yep, we can.
Thank you.
Believe me, I know any struggles you guys are having with this Zoom process, because I've been doing this 3 times a week now for 8 months and still struggle with Zoom.
Okay, can you see my screen?
I
Just need
can.
confirmation. All right.
Yep.
Beautiful. All right, so how do you start it? How do you start the presentation? And because I can't access the.
So go to slideshow. Is that what you want to do, to show this as a slideshow, or?
Yeah, slideshow. Yes.
Yeah. So you go see up at the top there, slideshow. So you got file, home, insert, draw, come across to slideshow. Yeah, so come across to your right.
I know where you're talking about, just it's blocked because of the content above, like the mute and the content of Zoom. That's why I can't get to it.
Yeah, so the one thing you can do is just leave it the way it is, because we can see your large slide, and then just use your scroll, you scroll down, and this is actually one of the things that I do struggle with as well. So yeah, if you just leave it like this and just use your scroll and your mouse, you can just scroll down to the next slide when you're ready to go.
Okay, that's fine. Yeah, I'll do it like this then.
Yep.
Very well. So good morning, everyone. Today I shall be discussing with you my topic pertaining to per and polyfluoroalkyl substances, or the other name goes by PFAS. So what is PFAS? PFAS is a type of acidic organic compound that is mainly composed of fluorocarbon substitutes. So as you can see here, the fluorine essentially acts as the hydrogen branch for the carbon units of the organic molecule. And to the left, you have the powerhouse, as it were, or that controls the entire molecule, the carboxylic acid branch with a carbon-oxygen double bond and a hydroxyl branch right there. And because this molecule retains stable bonds, such as pi and sigma, and the ions that are attached onto the molecule are very highly electronegative, it is excellently stable in any environment it encounters, whether it be aqueous or organic. It is also an excellent resistor towards heat, as well as dissolving in solutions such as oil, other stuffs like oils and water. And there are thousands of different variants of this chemical related to this class. So the use of PFAS can be traced all the way back to the 1930s, where the class substance was first invented as PTFE, or polytetrafluoroethylene. The legends here if you guys want clarity. The chemical wasn't officially used in the industry until the 1940s, where it was used in cookware products as a non-stick ingredient. And because of its excellent resistance and stability from other forms of substances, as well as heat, as mentioned before, the ingredient came on as a success in the chemical industry and was further expanded and developed, and then going into the 1950s for products against strain and water resistance, such as water drainage and such, and then went on to the 1960s, making into firefighter foam to help with extinguishing flames, and in textile products to help the product not get wet or soaked when you're in the rain, or if it gets soaked by any other substance, because it's very resistive. Unfortunately, PFAS hasn't been treated well in terms of waste, as you can see here, especially in our water sources, like our lakes and rivers. Here's a picture of Lake St. Clair in Windsor, Detroit. There's been a lot of foam hanging up on shore that has been containing excessive amounts of PFAS. And because it's been going up on shore, it's been contaminating the land as well as our crops and vegetation, which also leads to animals and humans alike getting affected by PFAS in certain dosages. And researchers have found this chemical to have severe long-term health effects. And the risks associated with PFAS include, but are not limited to, the increased risk of cancer, obesity and type 2 diabetes, hormonal disruption on fertility, and surprisingly, recently has been linked to carrying the risk of COVID-19. So really, we talk about taking safety measures of COVID-19, but at the same time, it's still an unclear pool, as it were, of where COVID-19 could potentially come from. And unfortunately, this is one of the substances that COVID-19 can be carried from, PFAS. Our stance on PFAS, the Canadian Environmental Protection Agency, or CEPA, has been responding to this issue regarding PFAS and its effects to health ever since it's been found in 1999, and are still doing their part until presently. One of the solutions that CEPA has made to prevent further PFAS contamination was, as of 2019, it has set guidelines for PFAS in drinking water to not more than 0.6 parts per billion, or 6 million parts per trillion. On an international scale, the U.S. Federal Detection Agency in the U.S. has been also setting guidelines for PFAS in drinking waters to 70 parts per trillion, especially for states like Michigan and California, where the PFAS levels in their water sources as well as their farmland has been like 10 times higher than any other state in the United States, especially in cities such as Detroit and San Francisco. In Europe, the manufacturing of PFAS in textile products has been set to contain not more than 1 microgram per square meter, so in products such as raincoats or jackets. And India and other countries in Asia have also been taking steps to combat the health-related issues pertaining to PFAS by applying guidelines set by other countries overall on an international stance, or also known as the International Standards Organization, ISO, to set allowable amounts in their drinking water and other products made in India. A lot of the products made in other Asian countries would be like clothing, most jackets, other stuff there. So in conclusion, PFAS is an extremely harmful substance to both human and animal health alike, as well as the environment as a whole. Environmental agencies all over the world, including our country, have been working on solutions to further prevent and hopefully eliminate the release of PFAS and substitute it with a more stable chemical that can be used in industry for products. And still, as of today, further research and confirmation is needed on the potential impacts that PFAS can have on the world as a whole. Any questions?
So any questions from any of the students? Any questions for Omar? I see Aaron has placed a question in the chat. Omar, can you see it? Okay, so Aaron is saying, was it specifically the PFAS lake foams that were found to be a transmission vector of COVID-19?
So it's not just the foam, Aaron. PFAS, like I said, has been found in other sources, both on land and in the water. So it's basically the PFAS, the polyfluoral or perfluoral alkyl substance that has been carrying the disease COVID-19 to other places. So it's not just the foam. No, it carries it on its own because it has bonds that are very highly electronegative, which are very attractive towards other molecules that are essentially just the COVID-19 sort of, I guess you could say, sticks to it, and it carries it along with itself into the environment, into ever-changing environments throughout the environment. So whether it goes on the foam that found in near Windsor, Michigan, Lake Sinclair, or even all the way to Malaysia or China in landfills in the dirt, it carries COVID-19 in general, if it's exposed to it. And if people, as well as also the factor that people have to be exposed to it as well. So there's been a study conducted up in Nunavut about Inuits actually getting affected by PFAS from eating, because in their culture they'll eat like beluga whales and such as part of their diet, and they've been getting affected by PFAS. And pregnant women have been exposing 10 times more PFAS to their babies that are born than the mother can actually carry. So it can be anywhere, Aaron.
Any
You're welcome.
any other questions for Omar? Okay, Omar, can you stop sharing your screen for a sec? I want to, actually, I might be able to do that. No, I can't.
Sharing?
Yeah, can you just stop your screen share?
Absolutely.
Actually, no, that's fine. I just figured out how to do it. I want to just throw a question out into the chat to the students, right? Okay, so what I will do is instead of putting it in the chat, how many students on this call are aware of the PFAS issue and aware of how significant this PFAS issue is to the environment and human health? Just raise your hands. Those of you who have heard about this, done any reading on this. I guess so. I mean, it doesn't sound like so Aaron knows, he's at least aware of it. Someone else has said only had a basic understanding. One of the things that Omar mentioned, and what I don't know if you guys picked up on it, but a lot of what is happening with PFAS is taking place in the state of Michigan. In Michigan, for whatever reason, well, I mean, I guess the reason is because there's been such a big issue identified with PFAS in the Sinclair River and in Lake Huron. but they're really kind of leading the charge against PFAS. And I happen to have a plant I deal with. It's located in Michigan. And this facility, they've managed to confirm that they have not had PFAS in their operations for at least 30 years. They have not had PFAS in the building. Yet today, the processed water coming from the process lines still contains PFAS at levels above the limits that the state of Michigan has set. So that facility, they've actually had to install a treatment system specific to PFAS, and it was an almost $1 million capital investment for the actual equipment, and they're under compliance programs to monitor their discharges from the treatment system to ensure the PFAS level stays below the limits that have been set. So they're trying to measure PFAS in the nanogram and picogram level in their wastewater, and like I say, it's really, really persistent, and it is going to become a really big issue in Canada as well. I don't know why, but we seem to be really slow getting going on the regulations surrounding this. I dread the day when municipalities put a PFAS limit into sanitary sewer discharges, because I know that we will have many plants that are going to struggle with this. And I don't know if Omar mentioned it, but one of the major uses for PFAS was 3M Scotchgard. And every time we would buy a couch or a new chair, we'd pay an extra couple of dollars to have it Scotch guarded. Well, Scotchgard contains significant levels of PFAS, and that material just does not degrade. So, it's out there in the environment, and I'm actually very impressed that Omar could tell us the full name of PFAS. Because it is. I even just go along with the acronym, but it's an emerging issue, and maybe an issue that a bunch of you guys are going to have to deal with as you move forward in your career. But just watch the news. There's regular articles. There was an article just a couple of weeks ago about how PFAS has been found in most women's cosmetics. So it's something that you really should try and pay some attention to. So thank you very much, Omar. I know that wasn't really a question for you. It was more of just a whole bunch of comments wrapped up, into a rambling 3 minutes. But I really do appreciate you doing that. It's an issue that is very close to my heart, because, as I say, we're struggling with this issue at one of our plants that we deal with in Michigan. So no other questions for Omar, right? Everyone good? Okay, all right. Thank you very much, Omar. So who is next here? Lacey Morgan. Are you ready to go, Lacey?
Yeah, I'm ready.
I'm impressed. You guys are all just ready to go ahead and do this. Okay. So what do you have for us, Lacey?
Just one sec. Sorry, I just have to allow it to share my screen.
Yeah, no, that's okay. So if you go down to the bottom, do you have like a green box down there that says, oh, you got it. There
Yeah,
you go.
you can see it?
Yep, perfect. That's a
Um,
nice bright slide to start off with.
Okay, so I'm doing mine on Duffin Creek Water Pollution Control Plant and the negative impact of phosphorus discharge. Okay. So located on the shores of Lake Ontario in the city of Pickering, the Duffin Creek Water Pollution Control Plant is a wastewater treatment facility that is part of the York Durham sewage system that consists of screening and aerated grit removal, rectangular primary clarifiers, aeration basins, round and rectangular secondary clarifiers, and liquid chlorine contact chambers for disinfection. Waste activated sludge is thickened with primary sludge in the primary clarifiers and is withdrawn and pumped to solids handling, anaerobic digestion, dewatering, and incineration. The plant has an underground outfall pipe that extends under the lake bed that have nozzles that extend above the lake bed to release treated water. And the plant is designed to protect water quality and aquatic life in Lake Ontario. This is just the steps of their wastewater treatment process. So the treatment process from the plant does not fully remove phosphorus, so the presence of algae has increased significantly along the shores of the town of Ajax. The overgrowth of algae can harm humans and ecosystems as they produce toxins, lower water oxygen, and block sunlight from the water column. After the expansion to the sewage plant in 2010, the annual average daily flow treatment capacity increased from 340 megaliters per day to 630 megaliters. Though the treatment capacity increased, the effluent total phosphorus load decreased from 420 kilograms per day to 311 kilograms per day annually. So sources of phosphorus come from detergents, fertilizers, runoff from farms, human excreta, food waste, household cleaning products, and commercial and industrial products. Major sources of phosphorus to the Duffin Creek Water Pollution Plant are residential sewage and industrial effluents. In 2008, the total annual Ontario total phosphorus load was 644 million tons, with Duffin being one of the top 5 loads at 90.8 million tons per year. The development of algae blooms occur from a variety of environmental factors, including available nutrients, sunlight, temperature, hydrology, ecosystem disturbance, and the water chemistry. Nutrient enrichment is a major factor. Phosphorus and nitrogen are the main nutrients that contribute to eutrophication. Phosphate attaches to sediments, and when dissolved oxygen concentration is low in the water, phosphate is released from sediments into the water column, which then increases algae growth. The high phosphorus levels in Lake Erie compared to Lake Ontario are much worse, as it resulted in cities in the United States shutting down their drinking water supply plants for periods of time. Major sources of phosphorus in Lake Erie are agricultural use of fertilizer and urban storm water runoff. In 2018, it was estimated a total of 11,467 tons of phosphorus loading to Lake Erie. So what is being done about this issue? In April 2014, the regional municipalities of Durham and York had undertaken a phosphorus reduction action plan study that was requested from the Minister of Environment and Climate Change. The outfall class environmental assessment completed in 2013 recommended enhancing phosphorus removal in the effluent and upgrade the outfall diffusers. That allowed the plant to operate at the treatment capacity of at least 630 megaliters per day, and iron salts were used in the treatment process to help remove phosphorus in suspended solids. The algae growth continued to be an issue with the amount of phosphorus being discharged. The regions retained a team of wastewater treatment experts at CH2M Hill Canada Limited to complete the phosphorus reduction action plan study and provided options of secondary treatment optimization that would include combinations of chemical addition or adding a tertiary treatment. So they suggested flocculation, cloth media filtration, deep bed filtration or membrane filtration. But it was determined that tertiary treatment was beyond current and proposed regulatory requirements and would have financial implications to the regions. The final recommendation from the phosphorus reduction action plan study was to implement secondary treatment optimization of chemically enhanced phosphorus removal in the existing secondary treatment process, which included aeration, and to proceed with modifying the outfall with variable diffuser ports. This creates a short-term solution. This implementation will maintain effluent phosphorus in the range of 0.35 milligrams per liter to 0.45 milligrams per liter on an annual average basis. The recommendation was approved by Ministry of the Environment and Climate Change Ontario, and the regions were to develop a plan to implement secondary treatment optimization over the next 1 to 3 years and replace diffuser ports as warranted by increased flows through the plant. The report was submitted on January 10th, 2018 to the Minister of Environment and Climate Change Ontario, and it was also posted on Durham.ca for 45 days for public review. And Duffins Creek treatment process will continue to reduce the amount of dissolved phosphorus exiting the facility in the future. And that's it.
Okay, thank you very much, Lacey. And once again, very interesting presentation. Does anyone have any questions for Lacey? I'm going to ask you just to keep sharing your screen for a minute.
Okay.
Any questions there? It doesn't look like there's any specific questions. I mean, this is a well researched presentation. The numbers that you've thrown out there for the amount of phosphorus loading are, I mean, they really are mind-boggling. Can you go back to your slide that shows, you know, the information that you have on the phosphorus loading to Lake Erie and Lake Ontario?
Yeah.
Let me just.
This
Yeah, so if you look at that one, right? So it was estimated a total of 11,467 tons of phosphorus loaded to Lake Erie. I mean, that's a mind-boggling amount of phosphorus, right? And when you stop and think of it, I mean, Lake Erie comes into Lake Ontario through Niagara Falls, so. I mean, that's a baseline loading to Lake Ontario, not on top of it. Can you go back another slide to what you have for Lake Ontario? I saw some numbers earlier for Lake Ontario. No, just right there. So,
yeah.
you know, so these loading to, and I'm assuming that these are the loading going into the facilities, you know, 644 million tons. With Dufferin being the top one in the top 5. I mean, that is huge, huge numbers for phosphorus. So after you've researched this presentation, do you think Duffins Creek is contributing to the algae problem that's been experienced along the coast in Ajax? Yeah, you do.
Yes.
Yeah, I mean, there's a lot of information out there online. The general consensus of the public is that the Duffins Creek water pollution plant is a major contributor to this problem. Because they discharge the phosphorus, even though the discharge is quite a distance out in the lake, it is still close to the shore. So the general consensus out in the general population is Duffins Creek is a significant contributor to it. But if you ask Durham region or York region, they will tell you that they don't believe it is. I see a couple of questions just kind of popped up there from Aaron. Can you see them, Lacey? I guess he said, I wonder if that's count total runoff in the Lake Erie Basin. Did you look at that? Did you look at where a lot of the phosphorus comes from that goes into Lake Erie?
No, I was trying to research that. I couldn't really find much information on that.
Yeah, so they say the biggest part of the issue to Lake Erie is runoff from agricultural fields, and I think primarily on the Ontario side of Lake Erie. So some of the things they're looking at is, how can they manage the application of phosphorus and nitrogen fertilizers to agricultural fields so that it's more efficiently applied, because essentially what happens is they apply it to fields. A couple of days later it rains, and a lot of that rain, because agricultural fields have drainage tiles, a lot of that phosphorus, it just gets applied to the ground surface, gets washed into the drainage tile. Those drainage tiles are connected to ditches that lead directly to Lake Erie, so a lot of it ends up in Lake Erie. And the Great Lakes Commission, if you ever go look at some of their stuff, they're looking at ways as to, how can they actually, one of the issues that they've identified is that we've removed a great number of the wetlands that were present along the shores of Lake Erie, and those wetlands would have uptaken a lot of the phosphorus and nitrogen, but they've been removed. So some of the solutions they're looking at is, can we reinstall some of these wetlands to uptake some of the fertilizer before it ends up in the lake. So again, thanks for your presentation, Lacey. It was very well done. And another issue that I have a great interest in, because it does affect the shore along Whitby and Oshawa as well. So thanks for doing that. Good job.
Thank you.
Okay, so who else do we have here?
I believe that would be me.
Curtis Murley. Yes, it would.
Me.
Okay, Curtis.
Just a second here. Are we in action?
Are we in action? Let me check. Yes, you are.
All right. For my presentation this morning, I'm going to be looking at groundwater, and most specifically, the industrial waste management of groundwater. The three key topics we're going to be looking at today will be what is groundwater and how does industrial waste enter the aquifer, the monitoring and sampling process of groundwater, and then also the industrial waste and water treatment process of groundwater. So to level out the playing field a little bit, what is groundwater and how does industrial waste enter the aquifer? Well, groundwater, as the name would suggest, is water that is in the ground. Similarly to surface water, contaminated groundwater can have a large area of effect, and this effect can be determined by various properties. Some of these properties include soil composition, the depth of the water, which can be related to the amount of rainfall, and the elevation and topography of the surrounding environment. Some potential methods of industrial waste that can enter the aquifer: underground storage tanks and underground pipeline leaks. So we had a wonderful presentation yesterday that mentioned nuclear waste being stored underground. There's this, along with other industrial or hazardous waste being stored underground, always is going to have a possibility of spilling into the soil, which directly goes into the groundwater. Also, in this course, we've looked at many hazardous waste carriers. Say there was ever an accident transporting hazardous waste, this would go directly into the groundwater as well. And then finally, older infrastructures of industrial facilities can also have leaks that, again, leak into the groundwater. So for that reason, we need to monitor groundwater pretty extensively in some areas. I have a picture here of one of 3 groundwater monitoring wells that are on the Oshawa Durham College campus. These wells can be used to measure various things, but related to industrial waste and industrial waste management. We could use them to determine if any of these industrial facilities or underground storage tanks or pipelines have had any leaks. Now, Vejna recently had a presentation which was quite extensive on the water treatment process. I'm going to repeat and kind of go into a similar detail on some of that process. we have this diagram here, which I really do like. It has lots of colors and it's easy to follow. However, in an industrial facility, there likely won't be a biological cleaning section here, and that would likely be replaced or in addition to a chemical cleaning section. Anyways, the beginning process can be water entered from the facility or from the groundwater, and that would go through a screening and grit and grease trap process. This is to separate any physical debris that might be in the water. The next step would be the water would go into the clarifier with the addition of a coagulant, such as, let's say, aluminum sulfate. And this is going to form flock. The flock can either settle on the bottom of the tank, or if with the use of dissolved oxygen can bring the flock to the surface, and the water and the flock or the sludge can be separated that way. Then the semi-treated water would go into the chemical cleaning basin, and then using exciting analytical chemistry techniques that we've done in class, whether it's ion exchange or oxidation or chemical precipitation, this could separate some of the unwanted metals or whatever it may be, contaminants from the water. And then again, that goes into a secondary clarifier, which even furthermore separates the unwanted material from the water. The unwanted material, whether that is organic material or metals or whatever it may be, is then dried and solidified to be disposed of or hopefully recycled. Different recycling opportunities for the sludge could be fertilizers, repurposing the metals, etc. The water is then treated and, is then directed towards likely a municipal water treatment plant to kind of undergo that biological cleaning process that this diagram does include. But likely that would include some sort of aeration or UV treatment. And then from there, that would go into household and drinking use. And that would conclude my presentation.
Okay, thanks, Curtis. Anyone have any questions for Curtis? No, no questions. So did you look at the regulations surrounding industrial facilities bringing groundwater back into the treatment facilities and then discharging that water to the sanitary sewer system? Did you look at that at all as part of your research?
Definitely had intentions to.
Yeah, didn't quite
Wasn't
make
quite
it.
sure how much the time limit was going to be.
Yeah, yeah. So
something I admitted.
yeah, so essentially, I mean, Curtis is right. Industrial facilities that have both a contaminated groundwater issue and also happen to have an industrial wastewater treatment system on site that can treat that water, they will, they will remove that water through pumping systems, put it through their wastewater treatment plant, then discharge it to the sanitary sewer system. One of the things that there's a couple of things you have to be careful about. You need to be sure that the wastewater treatment system can effectively remove the contaminants of concern. But the other thing is municipal sewer use bylaws generally prohibit the discharge of groundwater to the sanitary sewer system. So in cases where industrial facilities are doing this, they need to get a sewer discharge bylaw agreement in place with the municipalities before they do that. And Curtis was right in that most of the treatment systems at industrial facilities don't contain biological components to the treatment systems. There are certain facilities like food processing facilities, and we did deal with one that was actually connected to Bruce Power up on Lake Huron, where an apple cider was discharging their wastewater into the same wastewater stream as Bruce Water, and they had to install a biological treatment system to reduce the BOD content of the water before they did that. So once again, probably not any questions in that rambling comment, but thanks for your presentation, Curtis. It's definitely an important issue and worth looking at. Okay,
Yep.
any more questions
you.
for Curtis? No. Okay. Well, it is 10:04. I think we will end it there. A couple of people that were supposed to go today did not make it today, Aaron and Alyssa. So we will have you guys go first thing on December 2nd, and hopefully we can get through this on December 2nd, free up some time for December 3rd. Okay. Anyone have any questions? Somebody said, is there anything we need to print for the environmental lab today? Yes, there is. I tell you what, I will print them and I will bring them with me. Okay. Because I'm not sure if I actually posted that to DC Connect. Okay. All right. So if there's no other questions, then I will end it now. So thanks for all the presentations, and thanks for everyone attending. Okay. All right. Thank you. Bye.